Post.
Okay,
I think it just
I pressed a go live, so now it says you're live.
I resolved my problem as well. I apologize.
Okay, hold on. We're checking on the live screen, the live streaming. It should be all right. I am seeing the AOC document.
Okay.
Oh, it's up. I see it too.
Okay, well, I'm glad we checked on that. All right, are we ready to go back on record?
Yes, sir.
All right, let's go back on the record. Mr. McKay, please continue.
All right. Mr. Chang, as you consider the evidence and develop your recommendations, please bear in mind that the regulating agencies who are responsible for making sure that the Red Hill facility is safe are engaged to ensure that the facility does exactly that. The administrative order and consent, a separate enforcement action entered into between the Navy, the Department of Logistics Agency, or the Defense Logistics Agency, the Department of Health, and the US EPA, address tank upgrade alternatives, groundwater modeling, and tank inspection and repair process to ensure environmental protection. That action has already led to the implementation of significant improvements at the Red Hill facility and will continue to do so in the future. The work the Navy is performing under the Department of Health and US EPA supervision is done expressly to protect drinking water, natural resources, human health, and the environment. The administrative order on consent imposes binding obligations on the Navy, many of which you heard about during the hearing, and I'll address today. But first, one of the determinations that the Department of Health must make in deciding whether to issue a permit is whether the applicant can meet the requirements of the Hawaii Revised Statute, Chapter 342L, and the Department of Health's implementing rules for underground storage tanks. The evidence has shown that the Navy can, does, and will continue to do so moving forward. The Red Hill facility's physical operation and operational infrastructure has been upgraded with advanced design features that ensure it meets the current underground storage tank regulatory standards. For example, the Navy has an up-to-date environmental and safety plan and a spill prevention, control, and countermeasures plan. It has an integrated contingency plan and an emergency release response plan that requires the Navy to take immediate actions prescribed by federal and state regulations in case of any spill. The facility has been upgraded with advanced tank gauging and automated fuel handling equipment. The integrity of the tanks is tested using methods approved by a national working group on leak detection evaluations. This is a group made up of state and federal regulators who evaluate the leak detection techniques and then ensure that the test is reliable. The Navy is not ensuring that that test is reliable. It is done by an independent third-party oversight group. The carbon steel liner has been tested and meets modern industry standards for fuel compatibility. The Department of Health and the US EPA have inspected the facility and determined that it met or exceeded applicable standards and requirements. And while the Navy hasn't yet seen the formal results of the most recent inspection that took place in October 2020, the Department of Health did not indicate any immediate concerns to the Navy personnel who assisted them during the inspection. The testimony of the Navy's 10 witnesses was offered to explain relevance of over 100 Navy exhibits and 400 Board of Water Supply exhibits, many of which are publicly available state and federal government documents. The testimony and exhibits prove that the Navy maintains and operates the facility in a manner that is protective of human health and the environment. The Red Hill tanks were professionally engineered and well constructed. They are not a patchwork of steel and concrete, as the Board of Water Supply's expert suggested. As you learned, the facility was built in the middle of a war and was strategically located and constructed to survive bombing and withstand other natural hazards. Dr. Johnson's testimony is particularly instructive to understand the care that was utilized to construct these tanks. In Exhibit B12 of the Bechtel Survey in 1949 shows the sketch Dr. Johnson discussed in detail with you. He described how the the grout pre-stressed the concrete, which is indicated by the use of strain gauges, which he described as a state-of-the-art technique at the time. The measure was taken to ensure that the tank cavities could withstand the physical force and bear the weight of the fuel in much the same way that modern concrete structures are pre-stressed to make them stronger. Concrete structures are being constructed on the island today. From this figure, we can see how the builders used the red earth slurry of the gunite layer before they poured the concrete between the steel plate and the rock. This step ensured that the concrete cured and dried, it would cling to the steel, not the rock, and form the anti-corrosive passive film with a high pH. As we heard, this bond remains strong today, and some of the steel coupons that the Navy wanted to examine for its coupon testing could not even be pried free. And the concrete samples that the Navy tested remain within an alkaline range that helps protect the steel liner from corrosion. Importantly, the Navy uses the same inspection technique to identify corrosion that is used in fuel storage tanks throughout the world, wherever the bottom of an underground storage tank or the outside of an underground storage tank cannot be visually inspected. And as you can see from this chart, with this technology, we have found that extremely small percentages of the tanks have ever required repair due to concrete or to corrosion. This tells us that after 80 years of service, the vast majority of steel is being protected because it remains in contact with the concrete. The Navy's tank inspection, repair, and maintenance program for Red Hill was overseen and approved by the Hawaii Department of Health and US EPA pursuant to the AOC. Not only does the Navy's term program use methods recommended by the API standard for inspecting inaccessible tank services, but it adds layers of independent third-party qualified for quality control and heightened standard of care. The Navy's term program includes additional steps and adds a confirming prove-up process for each repair, which is designed to ensure that even marginal cases of thinning metal are caught and validated. The Navy's assumed corrosion rate doubles the assumed corrosion rate found in the API and adds a substantial safety factor to account for variability. The Navy's design corrosion rate is developed to identify and repair existing backside corrosion. The Navy calculates its corrosion rate properly using only the data that shows thinning from the tank exterior. In arguing otherwise, the Board of Water Supplies expert, Dr. Norfleet, he improperly incorporated areas that were overground from previous repairs of the interior of the tank to conclude that the Navy was somehow underestimating its corrosion rate on the backside of the steel line. But when he was cross-examined, Dr. Norfleet acknowledged that the welds, overground metal, tool marks should not be considered in calculating corrosion rates. Mr. Frank Kern, the Navy engineer who personally familiar with this particular repair, testified that Dr. Norfleet relied on a photograph that did not show corrosion, but in fact, it showed the area was overground during weld repairs. Dr. Norfleet not only concluded that the grinding was evidence of corrosion, he also claimed that it showed pervasive corrosion spreading from an area of a previous repair, neither of which was true. Similarly, there is nothing about the size of these tanks that affect the accuracy of the Navy's inspections process or make it impractical, as the Board of Water Supply suggests. As we see on the top image here, which we placed in front of your screen, this is Exhibit B192. The API 653 inspection report for Tank 16 shows the process. The Navy's low-frequency electromagnetic test examiner is inspecting the backside of a tank bottom on that top photograph. The operator is trained and certified to use this inspection method, and he's calibrated that tool. He's placed the LFET on the floor of the tank, and he's looking away at the screen to mark the result. The technology he's using, as Dr. Norfleet acknowledged, can detect pits as small as 62 thousandths of an inch and is just as reliable on a vertical surface as it is on a sloping or horizontal surface, and is used throughout the world. We can see from the bottom image that the inspector is examining the wall of the tank is in an identical position in relation to the metal, the LFET, the screen, and the bottom of than he was when he was inspecting the bottom of the tank. There's no basis to conclude that one kneeling on the bottom of a tank inspecting a horizontal surface is any more efficient than one standing using the same exact procedure. The Navy's inspection process is systematic and methodical. It is not rushed. It takes as long as necessary to inspect each metal plate with as many personnel as necessary to ensure the entire surface of the tank is examined. Just as washing windows on the exterior of a large office building, it may take longer if the building's bigger, but you're certainly not going to, it's going to be just as predictable and done with the same amount of care that the lower levels are done. It is an irrational comparison to say that we cannot inspect each tank liner with the same care. There's simply no support. We also have no reason to believe that corrosion on the backside of the steel liner will ever be the cause of major releases. As Commander Whittle testified, it's extremely unlikely that tiny holes from corrosion would ever lead to a substantial or sudden release, and the history of releases bears that out. Even if we accept Dr. Norfleet's calculation that 72 releases have occurred in the history of the facility, which we do not, we know that the vast majority of these were not caused by corrosion of the tank liner. For example, 30 of the releases, which is 41% of the total number of releases listed on Dr. Norfleet's chart, were detected in a telltale system. The telltale system was inside the tank and was installed partly to detect leaks from the tanks as they were constructed. We know from historical engineering records that each tank was filled with water during construction to detect leaks, and the telltale system was designed in part to capture and drain the water during the initial inspection. If there was a leak, water for testing could have made its way between the steel and the concrete and caused corrosion dating back to the original construction of the facility, not intruding groundwater. As Dr. Norfleet testified, determining when corrosion actually happens is the holy grail of detection technology. And currently we have no way of knowing or dating whether the corrosion we are finding today is from the original construction of the tanks. Later, the telltale system was exposed to salt water and settled on the bottom of the tanks, which corroded the telltale pipes from the inside of the tank. We also know that water settles on the bottom of fuel tanks as a common occurrence in this industry. So as holes develop in the bottom of the telltale system, water or fuel from inside the tank would have entered the telltale pipe and appeared as a release to the telltale system from the backside of the liner. Therefore, we do not know whether any of the reported telltale releases were releases of fuel to the environment. What we do know, however, is that the telltale system was unreliable. The Navy decommissioned it. Reported releases from the telltale system cannot be mistaken for releases from the tank, and they don't indicate the tanks had integrity issues. These account for 41% of all releases on Dr. Norfleet's chart. In addition, to the 30 telltale releases, 23 of the releases on the chart which account for the larger historical releases are associated with Tank 1. Tank 1 has been out of service for decades. And importantly, the chart also shows that most of the releases occurred before 1988. Since 1988, when modern standards and regulations for the maintenance, repair, and release responses were implemented, the accuracy of reported releases improved and the occurrence of releases significantly decreased. Therefore, the majority of the alleged historic releases are from unreliable systems that are no longer in use, from tanks that are no longer in service. They rest on a misinterpretation of work orders, or from other reported events that were never confirmed to be actual releases of fuel to the environment. In any case, however, very few can be contributed to corrosion that the Board of Water Supply has characterized as an unacceptable risk, and absolutely none since the Navy updated its corrosion repair program. I'd like to talk to you about the 2014 release. The evidence and testimony presented in this hearing show that there has been only one significant release of fuel into the environment in the last several decades, and that release was not due to corrosion. In 2014, a contractor repairing the tank at the Red Hill facility failed to properly seal holes that were drilled to release vapors in the tank in the repair process. After the contractor certified the tank, the Navy filled it and fuel was released through the unrepaired holes. Automatic alarms sounded, but the tank operator silenced them. The operator's confidence in the contractor's work was misplaced. The gauging and alarm systems were accurate. The set of quality control operator failures that led to that release of approximately 27,000 gallons from tank 5 had changed. Importantly, the soil vapor monitoring also detected that release. In order to address the problems that led to the 2014 release and ensure it would not be repeated, the Navy entered into the administrative order and consent with the Hawaii Department of Health and US EPA. As I discussed and stated, this is a binding agreement that imposes obligations on the Navy that extend beyond the 5-year term of the permitted issue. The primary objective of the AOC, as seen on your screen, are to take steps to ensure that the groundwater resource in the vicinity of the facility is protected, to ensure that the facility is operated and maintained in an environmentally protected manner. The Navy and the DLA The Hawaii Department of Health and the US EPA all agree that these objectives can best be accomplished, ensuring that the tanks and other infrastructure at the facility deploy the best available practicable technology to prevent releases and better understand the hydrogeology around the facility. The statement of work that accompanies the AOC that the Navy will complete to comply with the AOC is divided into 8 sections, the first of which is just a summary and overview. The remaining sections are substantive, and they were designed to accomplish several important tasks. Under Section 2, the Navy improved its tank inspection, repair, and maintenance procedures. Although the term has already been approved by the regulators as being implemented, the Navy's not stopping there. It's engaged experts at the University of Hawaii and elsewhere to continue to upgrade the process on a 5-year review cycle. Section 3 called for the study to evaluate potential tank upgrade alternatives that can be implemented at the site. After the study is complete, the DOH and the EPA will approve one or more of the best available practicable technologies, and the Navy will implement that option. The alternatives under consideration include secondary containment, coatings, liners, and enhanced release detection methods, among others. In the meantime, the Navy is also implementing prudent near-term measures, including the installation of high-precision leak detection hardware and decommissioning the tank's nozzles that may pose risk. AOC Section 4 required the Navy to increase its tank tightness testing from biannual to annual, conforming to the HAR requirement for field constructed tanks. But the Navy has gone above and beyond this regulatory minimum and now tests each tank twice a year. And as you heard from the Navy's witness, Mr. Chris Caputi, no tank has ever failed these independently verified tests since the Navy began testing in 2008, including Tank 5 before it was taken out of service in 2010. At the direction of the regulators, the Navy is also working to improve the other types of release detection technology used at Red Hill. Under Section 5, the Navy is evaluating possible improvements upon the industry standard methods of corrosion detection and mitigation that it uses. It is already confirmed that metal fatigue is not a significant issue at Red Hill, and it has submitted a new destructive testing work plan to improve the inspection process. Section 6 and 7 require the Navy to develop models for groundwater flow, contaminant fate, and transport, subject to the approval of the DOH and the EPA. The regulators approved the scope of work for the groundwater flow modeling, and the Navy has performed the specified work within the continuous assistance, commentary, oversight of the regulatory agencies. All of the data collected in the course of this work has been made available to the regulatory agencies and the public, with the limited exception of certain proprietary information or Department of Defense critical infrastructure information. Finally, Section 8 of the AOC required the Navy to develop a risk and vulnerability assessment to understand the potential for future releases and help the parties make decisions about the best available technology to use. The Navy has completed the first phase of the risk assessment, which identified possible risk factors internal to the facility. The second phase of the risk analysis will focus on the external events and is in the process. Although the Board of Water Supply and the Sierra Club have tried to focus your attention on this report's statistical predictions of possible future events, the intent of the study, as the DOH and the EPA agree, was to provide valuable information regarding the relative factors contributing to risk. Based on this analysis, the Navy is taking the steps to address the areas of potential risk that were identified in the report so the predicted releases do not come to pass. For example, the first phase of the analysis found that almost a quarter of the total risk, which is the gray portion on the screen in the pie chart, is associated with the possibility of releases from small nozzles. Mr. Chang, you visited the facility. You saw the small nozzles protruding from the concrete plug in the bottom of the tank. They're approximately 10 to 12 feet above your head. It's worth noting that despite the fact that the small nozzles leaks make up over 23% of the actual risk identified in the QVR, there has never been a release from a small nozzle in over 80 years of operation at Red Hill. Nonetheless, when the Navy performs its new term process on each tank, it's removing these small nozzles to eliminate any possibility that they will leak. Moreover, and this is important, the QRVA determined that operator actions are generally more important than equipment failures to overall risk. In response to that finding, as Mr. John Floyd explained in his testimony, the Navy has increased training requirements, it's revised its response action plans, elevated decision-making authority to the fuels officer and assistant fuels officer. With each of these, the Navy reduces the risk. Mr. Chang, Red Hill is not leaking. Given all this work, all of the data gathered, all the studies and improvements, and all the evidence that has been presented to you, the only reasonable conclusion is that the Red Hill tanks are not leaking and the drinking water is safe. You've heard the Navy's tank tightening testing procedures meet the regulatory requirements for leak detection, but they have a minimal but detectable leak rate, which undetected leaks are not possible. Because that's true, the Navy also employs continuous gauging, automatic inventory controls, long-term inventory trend analysis, daily visual inspections, and soil monitoring beneath each tank, soil vapor monitoring beneath each tank. Even if a tiny leak occurs, the Navy will detect it and respond. To be even more certain, the Navy is working to install a permanent enhanced for leak detection equipment in each tank and convert the soil vapor monitoring well network into continuous operation. We also know that past releases have never impacted the drinking water throughout Red Hill's entire history of operation. You've heard testimony that the petroleum products biodegrade over time, and we have data to show that that is in fact happening in both rock layers, under the tanks, and in the aquifer. We have measured elevated temperatures of detected carbon dioxide fluxes that show biodegradation is occurring just below the tanks. But even better evidence is that the analysis of the TPH compounds in the monitoring wells just under the facility, we have found they are largely composed of biodegraded fuel constituents. The Navy began monitoring the groundwater in 2005 with just 3 wells directly underneath the tanks in this picture. That network expanded to the 6 wells before the 2014 release and now includes over 20 wells. This map does not include some recently installed wells, nor does it even capture wells that are being installed today as we speak. None of the newer wells, which you can see in blue on the map, have ever shown evidence of fuel constituents. This includes the monitoring well the Board of Water Supply installed near the tanks. As you have heard, neither the Navy's drinking water well nor the Board of Water Supply's closest drinking water shaft have ever been impacted. And yet the Navy continues to budget, plan, and coordinate with the DOH and the EPA to install more ground monitoring wells. All of the groundwater monitoring wells result in the past 15 years have been published on governmental websites that any member of the public can access. They confirm that the facility's limited impacts are not increasing or spreading. The Sierra Club and the Board of Water Supply both contend the Navy cannot completely rule out the possibility that something bad may happen at some point in the future. Dr. DeNovio, an expert for the Board of Water Supply, testified that she cannot rule out that a molecule of fuel has moved off-site. And Ms. Gannon argued in her opening statement the Department of Health should issue no permit until the Board of Water Supply is satisfied that the risk is really, really small. The Navy has undertaken every practicable step to reduce the risk of future releases, and the Board of Water Supply remain unsatisfied. It may simply be that there is nothing the Navy can reasonably do, including fulfilling each of its existing commitments under the administrative order and consent that will satisfy them. In light of the foregoing evidence and the testimony, and the Navy's ongoing work under the AOC to ensure that the already small risks remain as small as reasonably possible, the Department of Health should finalize the draft permit that it issued in May of 2019, which is expressly conditioned on the Navy's ongoing compliance with Section 2 and 4 of the AOC. Mr. Chang, the Navy certainly appreciates your time and patience last week and this morning, and we thank you for your careful consideration of these very critical issues you've been presented with.
Thank you, Mr. McKay. Ms. Gannett, will you be presenting the argument for Board of Water Supply?
I will, here, Mr. Chang, and thank you very much for the opportunity to discuss with you the evidence that you heard last week. The Board of Water Supply brought this contested case because we're really, really concerned about what can happen to the water on Oahu with the continued operation of these tanks as they are proposed in the permit application. We were hoping, we've been, as you heard throughout this proceeding, we've been involved with the AOC, and we've been trying to gather information for many, many years about what is happening at this facility and what the risks are. And we were hoping through this proceeding that the Navy could present a case that would demonstrate that this facility could be operated in a way that's consistent with state law. That's really what we would have loved to have heard. But unfortunately, that's not what we heard. And I think when you look back at the evidence, I think you have to agree that's not what you heard either. What we heard from a lot of the witnesses, we had 10 witnesses from the Navy. When you look back at what was said with each one of those witnesses, so many times we were asking them questions and their response was, I don't know. That's outside my area. I can't answer that. I don't know. We don't know. That's not us. Their risk expert says, I'm not an expert in risk. I can't talk to that. The person who's in charge of the term says, I can't talk to that in the AOC because that's not my area. That's not good enough. That is not evidence that shows that they can meet the requirements of state law. And so unfortunately, we have to ask you again this morning to take a careful look at everything before you and come to the only reasonable conclusion we think you can make, which is that the Navy has not met its burden, and it has the burden of demonstrating that it can comply with state law with the way that it has proposed to run and maintain this facility. Let's start by walking through what are the requirements of state law. We start off with the Constitution, the overall requirement that that it's a responsibility of the Department of Health and the Board of Water Supply to make sure that we are protecting our precious, irreplaceable groundwater resource. And you simply cannot issue a permit to this facility and satisfy that requirement. Then let's go to the statute. Let's go to 342L. 342L says you cannot have an underground storage tank facility that is leaking into the environment. We have an underground storage facility which has millions of gallons of fuel, which is known to have leaked into the environment, which is most likely continuing to leak into the environment today, and which is expected, when you look at the risk analysis that's been done, it's expected to leak both chronically and potentially catastrophically into the future. And when we talked, they put on Ms. Smith as their expert in regulations and to walk us through how they could satisfy all these requirements. And if you'll recall, it was on Monday, I was talking to her. And you might recall, I asked her, can you run a leaking facility? Like, can a facility that leaks be permitted under state law? And what did she say? She said, yes, as long as you repair it. That's not what the state law says. State law says you cannot have a leaking facility. Do we recognize that sometimes something could happen that can't be foreseen, that would have to be corrected? Absolutely, 100%. That's not what we're talking about. We're not talking about a situation where there's unexpected leaks. We know what's happened. We know about the condition. We have so much information now about this facility. And the only conclusion you can say is that this is going to be a facility that leaks. Ms. Smith saying that sometimes they're going to repair them when it happens, and that's going to be okay. That's not good enough. That's not what the wisdom of the Hawaii legislator did when they passed their underground storage tank regulations. They wisely said, you have to have systems that are constructed, operated, and maintained such that there are no leaks. The Red Hill facility simply cannot do. Now let's go to the regulations. And let's recall some of the conversations we had with Ms. Smith about a couple of the regulations in particular. Once Ms. Smith corrected her testimony and admitted that the corrosion protection part of the regulations applies to underground storage tanks and not just to underground storage tanks that come in contact with the ground, she was asked, okay, how does Red Hill make that? How does it meet that requirement? And what was her response? She said they're clad or jacketed. So if you remember, then we went to that part of the regulation which defines clad and jacketing. And I asked her, which section? There's 4 or 5 options, so 4 or 5 ways you can meet it. I said, which one of those 4 or 5 ways do you meet the clad or jacketing definition? What was her response? I don't know. She said, I don't know. I can't say. That's not good enough. That's not meeting a burden. There's nowhere in the record that shows how they meet that requirement. And then you remember there's another requirement that says, and she admitted this applies to Red Hill, because she has to, because that's what the regulations say. And this part of the regulation says that when you repair a tank, before you put it back online, you have to make sure that it's really, really, you've looked at it. You got to have a higher level of the tank tightness testing. And that's where it said, remember, instead of the 0.5 gallons per hour that applies to the regular tank tightness testing, you have to meet 0.1 gallon per hour. And that's what you have to do when you're going to bring it back online. That's what the regs say. It's very clear. And she even referenced that provision in her testimony when she was saying, they meet everything, we're good to go. But when I asked her, and I didn't just ask her, I asked her, and Mr. Brown talked to several people about this too, who were the people who are involved in the tank tightness testing for Red Hill. When we asked them, can you meet 0.1? They said, we don't know. We don't know. When I asked them, did you meet it for tank 5 before you put it back online? The answer was no. So the only conclusion is they simply cannot meet the requirements of the Constitution, of the statute, of the regulations. And the last part of the regulations, which is probably the most important part of the regulations, which says you have to be able to operate these tanks in a way that is consistent with protecting human health and the environment. And I put forth to you that there's simply no way you can look at the evidence that's been given to you this week and conclude that they have met their burden to demonstrate that they can do that. And we have to start off by looking at prevention. How do you prevent the millions of gallons of fuel that are sitting 100 feet above our precious irreplaceable water source? How do you prevent that from ever getting out? And you remember, I dramatically moved around a coffee store on Monday. And that was to demonstrate that there's a 1/4 inch of steel. That's it. And they haven't demonstrated that there's anything else. It's a 1/4 inch of steel liner. That's the only thing that keeps the fuel out of the environment. You heard the witnesses, many of them. They all eventually had to agree. Some of them, it took a little while to get them there, but they all eventually had to agree. When the fuel gets out of the tanks, when it gets out of the pipes, when it gets out of the nozzle, when it gets out of the system, it can get through the concrete, because we heard their witnesses agree, concrete cracks. Concrete is not impermeable. You get through the concrete, it gets through the grout, it gets through the gunite, it can get through the rocks, and it gets to the water and the soil. It gets to the environment. Everybody agrees. There's no doubt. That's all that's I don't think anyone can argue about that. So that's steel. That little tiny piece of steel is the only thing we got. And that's the only thing that's going to protect us. And what do we know about that steel? We know that steel is corroding. Everybody knows that. Everybody agrees with that. You saw those pictures. You saw the pictures. Everyone, they took out 10 coupons. That's all they've ever looked at. And every single one of them has corrosion on it. How can you not think we have to be worried about them, these huge tanks? If the 10 little windows we took into the world are all corroding, what about those acres and acres and acres of steel that's up? So we know it's corroded. And we know there's nothing, the way that these things are currently built, there's nothing they can do about that. All they can do about it, because they can't put corrosion protection on it. We know that concrete pressed up right against it can cause some protection. But we also know when they took out those coupons, 80% of them weren't actually in contact. So there's a huge, huge concern here. So what do we rely upon? Well, we talked an awful lot about the term process and the way that the way they engage their inspection and repair and maintenance. And that really is the only thing you can do, the way they exist today. But what do we know about that? We know that when they did it and when they tried to prove it out with destructive testing, 50% of the time they were wrong. 50%. Now, would you say I'm going to drive my car if 50% of the time I'm going to get a car accident? Would I let my kid go outside if I thought 50% of the time they might be kidnapped? We're talking about things that are catastrophical results, and we're 50%. That's not good enough. That is not meeting any burden of proof. We simply cannot accept that level of risk. And we have the additional problem. Not only is it not reliable 50% of the time, but they don't even inspect the tanks that often. You know, we've been told, yes, they're going to do it more frequently. They're going to try to do it every 20 years. But so far, I don't have enough evidence to rely upon anything that they've said or committed to, because the evidence shows they haven't been able to do it. I'm sure they want to be able to do it. I'm sure they intend to be able to do it, but it's complicated. It's a hard process. And so they're not doing it. And so we've got tanks out there that haven't been examined, that there's almost a quarter of the tanks. They've never even done an API inspection on them once. So we've never had even a really close look at how those tanks are doing. And even the ones where there's been API tests done on them, many of those, it's now been 30 years. So we really have no way of knowing how these tanks are performing. And so, you know, is it likely the whole thing is going to collapse and fail? No, probably not. But if they're leaking, just even chronically leaking, even leaking 5,000-6,000 gallons a year, you got 18 of these tanks out there. Sometimes that all could be full. You got 14 tanks out there right now that are full or are holding fuel. Each one of those is just leaking 5,000 gallons a year. The consequences to our environment are catastrophic. We cannot live with this risk. It simply is not allowable. So we have to go and look at what other methods do they have. Well, everything else they have is really about detection. It's about finding out where the fuel has gone after it's left the tanks and after it's gotten into the environment. And I put forth to you that's not good enough. You know, there are problems with the way that they detect things, but even to rely upon that as somehow demonstrating that they can meet the requirements of state law, that's just not consistent with the way the state law is written. It's not that we detect problems after they happen, it's we're supposed to be preventing them. We're supposed to be protecting our water, not monitoring how bad it gets. And what do they do with their monitoring? Well, they have the vapor monitors now, which we applaud them for putting them in. We think that's a very good thing. It does help us at least know, maybe when we have a problem, that we can know a little bit sooner. But what did the soil vapor monitoring show us? It showed us that the vapors are actually not just contained within the footprint of the tanks. It shows that it was actually spreading out. So vapor, and since we have many more vapor monitoring wells than we do water monitoring wells, you got to take that pretty seriously. We got to look at that. And what that showed is that the vapor moved. So when the release happened in 2014, you got this spike of vapor, and it moved pretty widely. So that's a pretty good indication that if there's other releases, we're going to have really big problems. And this is not acceptable. And then we look at the monitoring wells, and we can say, yes, we've got 3 monitoring wells installed under this 13-acre about facility. Again, 3 wells, 2 inches each, one of them not properly installed. And they want us to rely upon that to say, okay, we know where that fuel is, even though we've never been able to find it, even though we did an extensive investigation after 2014, and we looked everywhere, we never could find the fuel. But based on our readings from these 3 wells, we know for certainty that it's never gone anywhere else, right? It's all here. Well, what those wells really tell us, they really tell us that our water's been impacted. They really tell us that the law's already been violated. So we already have a problem. And then they tell us it's okay because these perimeter wells that we have, they show that it hasn't gone very far. And again, we represent, and Dr. Zanobio's testimony spoke to this, is that that network is not enough to tell us anything. And even Curtis Stanley, the Navy's witness, says, yeah, we need more wells. We got to get more information so we can understand this. And we're putting them in, so that's good. And you heard Mr. Kawada say, we applaud the Navy for putting more wells in. We absolutely do. We think that that's necessary, and we need that information. However, the facility that's in the permit before you doesn't have those extra wells. It doesn't have that layer of protection. This is simply not good enough. This is not consistent with state law, and it cannot be permitted. And we talked a lot about the AOC. And I understand that you've been struggling, and I know I've struggled with understanding how does the AOC and the permit kind of line up. Is one harder than the other? Does one mean one thing, the other means something else? And I'd like to share with you my thoughts on that subject. First off, it's important to remember the AOC is not a permit. It says so itself. But the AOC is designed to try to get to the place where identifying what is a way that you can operate this facility in a way that's protective of the environment and human health, and to understand the best practical way to do that. And so there is an alignment between these, because you need to decide if the facility that's described in that permit application is protective of human health and the environment. And the AOC says one of our goals is to figure out what's the practical way you can be protective of human health and the environment. So again, there's a lot of overlap, but the AOC is not a permit. The AOC does not satisfy the requirements of Hawaii state law. You have to make a separate determination. But I think that the Navy's performance under the AOC should really inform your consideration of this facility, and should really inform the way that you think about the way that the Navy has performed to date and the way that they're likely to perform in the future. And let's take a little bit of a closer look at that. Almost every document that's been submitted under the AOC has been found to be deficient. When it was first submitted, it was found to be deficient. Sometimes they were conditionally approved after that. Many of them they're still working on. They say to you that that section 2, which is the TIRM, they say, well, that one's done. And it's true. They did get that approved once. But it's not that we're just doing a regular 5-year cycle and they're going to have to go back and do it again. No, what happened was under a later section, under section 5, they were supposed to prove up the effectiveness and the validity of their method under their TIRM. And that's when I was talking about the 50% number. So when we looked at it, when they actually had to try to prove it up, what they found they couldn't. And so what did DOH and the EPA say in response to that? They said, you haven't proven up the validity. And so you got to go back and redo and improve the TIRM. So that's where we are. So yes, technically they got it approved once, but not really, because they couldn't prove it up to be valid as it needed to do in a later sequence of it. And then we had what we've talked a lot about is the TUA decision, which is the tank upgrade alternative. And you saw that in October. That was found to be deficient. And they have offered evidence saying that's just this iterative process back and forth, back and forth. But I tell you, when you look at the record, you can't find a place where the agency, the EPA and the Department of Health, looked at what the Navy has proposed and said you met the requirements. You won't find that because it has not happened. And it's really critical to remember that the alternative that was considered in the TUA had a bunch more protective stuff that they were proposing to do that is not in the application before you. So the thing, the concept, the proposal, the design that the agencies have already found to be deficient has more protection than what's in front of you today. That can't possibly meet the requirements of the Constitution, of the statute, of the regulation. It can't possibly be found to be adequately protective of human health and the environment. So again, we ask you, on behalf of the people of Oahu, on behalf of the Board of Water Supply, to look carefully and critically at this evidence. Don't take it at face value. Don't take empty promises. Look at this. See what's out there. Look at this facility and make a determination based upon the evidence before you. And we are confident that the only conclusion is that this does not meet the requirement. It must be denied. And we ask that you make the Navy find another place to put this facility, or to install double walls, secondary containment, so that we can actually have protection of our environment and still contain this facility. And again, we hope that with the review of the evidence, you will come to that conclusion. We thank you for your time and consideration. I know it was a long week. I know there was a lot of information provided, and we really, really appreciate the caring consideration.
All right, thank you. Madam Court Reporter, are you okay to continue? And parties, are you all ready to continue? Or do you want a break?
I'm fine.
Councils, you want to continue?
We're happy to continue if Mr. Frankel's ready.
We are as well.
Okay, let's continue. Mr. Frankel for the Sierra Club.
In 2002, a Navy audit determined that the environment in the Pearl Harbor area was not sufficiently protected from the tanks at Red Hill. That's exhibit B11, page 2. 11 years later, the Navy has failed to meet its burden to prove that that 2010 determination it made itself is no longer true. There are 4 reasons why the Department of Health cannot approve the Navy's application. First, the tanks will leak. Second, the Navy has failed to show that its tanks are protective of our groundwater from the threats of corrosion and earthquakes. Third, the Navy has failed to show that its recent efforts to protect our water are adequate. And finally, the future of our sole source aquifer is at stake. So first, the tanks will leak. Exhibit S17 describes this report, Exhibit N31. And it says that it is, quote, an in-depth, rigorous, and repeatable approach to assessing risk. Those are the Navy's words with which the Department of Health and the Environmental Protection Agency agreed. This report looked at risks of leaks leaving the facility, despite what you might have heard from one of the Navy's witnesses. That's the risk it was looking at. This report concluded that there was a 26.6% chance of a leak of between 1,000 and 30,000 gallons occurring in any single year. Professor Tom Ramsey looked at the number, looked at the statistics, and using generally accepted statistical methods, was able to explain and show that that means that over the next 5 years, the length of the permit, if the Department of Health were to grant the permit, that the probability of a leak of between 1,000 and 30,000 gallons is 80.1%. 80.1% chance of a leak of up to 30,000 gallons. That's the Navy study, a 1,666 page rigorous study using the best available tools for risk assessment. That study also showed, in addition to those acute risks, that for chronic releases, continual releases, it was expected that fuel releases of 5,803 gallons per year for the entire facility. Again, that's exhibit N31, page ES-5. This risk assessment was based on fundamental assumptions to do the study. One of those assumptions is that each main storage tank undergoes a major API 653 inspection once every 20 years. But we know that assumption is not true. We know that 3 of the tanks have not been inspected, any kind of inspection, in over 38 years. And another 5 tanks have not been inspected in over 22 years. So we face more risk than this study assumed. Now, the Navy points to the fact that another assumption of the study was that 18 tanks would be in service at any time. And it's true, there's only 14 tanks now. So one would think, yeah, the risk is a little smaller, but not a lot smaller. In order to reduce the risk in half, you'd have to have half the number of tanks operating. So instead of 18 being in service, as is the assumption, you'd have to have 9. But we know that there's 14. So even if you took half the tanks out of commission, you're reducing the risk at the most a half, which is still a substantial risk. As Professor Ramsey explained in his declaration, the risk is 80.1% over the next 5 years of a leak of up to 30,000 gallons. And by the way, the Navy never challenged his statistical analysis. This is a serious risk that the tanks will leak. And the Navy has failed to meet its burden to show that these tanks will not leak, as they must do under our law. Second issue, the Navy has failed to show its tanks are protective of our groundwater from the threat of corrosion and earthquakes. Let's look at corrosion first. This is from Exhibit N10. It talks about a leak, a blister, rust through from the backside. There was a weld patch needed over the leak. This is disturbing evidence from the Navy's files of how significant the risk is, the significant risk that corrosion posed to these tanks. Looking at Exhibit B11, this is alarming. The Navy says coating defects were also detected during these inspections, resulting in repairs to 57 corroded areas on the interior surface of the tanks, including 1 through hole in tank 2. These types of defects may potentially exist in the remaining 13 active Red Hill tanks that have not been inspected using the modified API 653 methodology. If similar defects exist and are not corrected, there is a risk of fuel releases from the Red Hill tanks. The report continues. The modified API 653 inspections identified 206 areas of exterior corrosion, which had diminished the thickness of the tank's liners. The corroded areas were caused by groundwater coming in contact with the tanks. Finally, as we all know, a NFESC corrosion engineer explained that this corrosion cannot be prevented at Red Hill due to the construction of the tanks. The print here is pretty small, but this is the report again. It's damning. The inspection of tank 16 revealed a cluster of exterior corrosion, 23 flaws, and 2 through holes within the cluster. The Navy's witnesses poo-poo the problem of corrosion. This is not an issue that should be minimized or trivialized. As Ms. Gannon just pointed out to you, Hawaii's underground storage tank rules require 11-280.1-20B that tanks must be protected from corrosion. Subsection 3, which is the section that the Navy points to, says the tank is constructed of steel and clad or jacketed with a non-corrodable material. Now, the Board of Water Supply's witness explained in great detail why this subsection does not apply to the tanks at Red Hill. But the Navy contends that it does. Well, if it does, as Ms. Gannon pointed out, 11-280.1-6C comes into play. The following codes of practice may be used to comply with that section cited above. And the Navy is not able to articulate how its tanks comply with any of these 4 codes of practice. The Navy has failed to meet its burden of proof. Moreover, the Navy's attempts to reassure us are undermined by the Department of Health and the EPA's concern that the Navy is both underestimating corrosion rates and that corrosion rates may in fact be increasing. Let's turn to earthquakes, the second threat that the Navy fails to address, fails to meet its burden of proof on. The Navy relies on this PEMI report. The PEMI report is, I don't know, about 7 or 9 pages long. And it's fundamentally flawed. It says Red Hill has not experienced a catastrophic failure event over the facility's 70-year operating history. It also says there are no records of dam earthquakes occurring close to the site. Maybe it's wordsmithing, but it's the PEMI report is clearly wrong. As the Bechtel report, Exhibit S-1 reveals, after an earth disturbance on June 28, 1948, there was a loss of approximately 850 barrels of fuel. And the fact remains, the Navy has not completed a rigorous study that analyzes the impact that an earthquake of the size of the 1948 earthquake could have, let alone a stronger earthquake. That is their burden. They have failed to meet this burden. The third major issue. The Navy has failed to show that its efforts are adequate to protect the environment. The Navy has pointed to 3 things in this hearing, or I'm going to highlight at least 3 of their things. One is they talk about the coating that they want to apply. Well, first of all, this coating, this polysulfide coating, has only been applied to 1 tank that's in operation. So if this coating is so important, we should be alarmed that so many tanks are operating without this coating. But more importantly, as the Navy's own witness has testified, that coating on the interior of the tank does nothing to the corrosion on the outside of the tanks. So their mitigation measure is insufficient to address the problem facing these tanks. A second mitigation measure they mentioned, removing the small nozzles, which their consultant recognized as posing a risk. To date, only 1 nozzle has been removed. So tanks are operating with this identified risk remaining. Let's turn to the third category of a third mitigation measure, is actions. The Navy touts its new inspection regimen. We can all agree inspections are important. Here's from Exhibit B11. Until the current inspection cycle is completed, any previously undetected areas of exterior corrosion may continue to worsen, may cause the remaining tanks to be susceptible to through holes, and could potentially result in future fuel releases. The Navy's own document reveals how important completing the inspection cycle is. And again, the importance of completing these inspections is highlighted by Exhibit N-81 at page 3. It reads, the tank inspection, this is of tank 30, the tank that we visited, revealed that mandatory repairs are required to return the tank to service. Mandatory repairs are considered actions necessary to preserve or restore the structural and hydraulic integrity of the tank. This is not just some box to check as suggested by, I believe it's Commander Frame. These are fundamentally important tasks, these inspections, because when you do an inspection and you find that there's a problem that needs to be fixed, it highlights the importance of doing those inspections. If you don't look, you're not going to find. So we know these inspections are important, and they're important to find backside corrosion, which is important which actually can undermine the hydraulic integrity of the tank. You were shown, I think it was on Friday, that machine that they used, I can't even remember the name, a handheld device to look at that can detect corrosion on the backside of the tank. I want to point you to Exhibit N112. This is the controversial exhibit that was entered into the record on Friday over the objections of the Board of Water Supply and the Sierra Club. So this is the Navy's exhibit. And what does the Navy's own exhibit say? It says, adherent steel corrosion products on the back side of the plates could affect the LFET signals and indicate remaining wall thickness greater than actual values. In other words, that little machine at times may overestimate the thickness of the metal, which means it is not doing a sufficient job of giving us the information we need to ensure that those tanks are thick enough, that they are not susceptible to through holes and the like. But perhaps more important than the quality of the inspection is the frequency, an issue that we touched on quite a bit. Exhibit B6 or Exhibit N-77, which is the TIRM report, highlights the inadequate frequency of inspections. These inspections are supposed to be done every 10 years, unless the corrosion rate is such that it can be inspected later, i.e. 20 years. Now, we already know that the 20-year inspection date is based on a corrosion rate that's probably not conservative enough. In any case, the Navy's not coming close to meeting its inspection schedule. 3, 4, and 11 were inspected more than 38 years ago. And they've never encountered one of these rigorous inspections. Tanks 7, 8, 9, 10, and 12 were inspected more than 22 years ago. So clearly, the Navy's inspection schedule is not frequent enough to ensure that these tanks do not leak and that these tanks are protective of the environment. And when they do their inspections, again, this is from N12, the controversial bit entered into record on Friday. This is the Navy's own document, and this is not very assuring. The current solution, this is on PDF page 87, by the way. The current solution is a literal Band-Aid. Where a tank wall has lost thickness due to corrosion, an extra layer of steel is welded in place to retain structural integrity. That should not give any of us comfort. Finally, the fourth issue. The future of our sole source aquifer is at stake. The Environmental Protection Agency back in 1987 designated the Southern Oahu Basal Aquifer as the sole source, the principal source of drinking water for hundreds of thousands of residents, that if contaminated would create significant public health. One of the main threats the EPA identified back then were military sources. And we know that the military has contaminated our sole source aquifer. Exhibit B8. The results of this investigation clearly indicate that petroleum has been released from the facility in the past. 3 groundwater monitoring wells were installed within the lower access tunnel of the facility, and samples from each have consistently detected petroleum dissolved in the groundwater beneath the site. The current level of impact to the environment exceeds the Tier 1 action level standard developed by the Hawaii Department of Health for groundwater that will be used as drinking water. It is, by the way, Hearings Officer Chang, irrelevant whether this water is currently being used as drinking water today. The only thing that matters is our groundwater, which could be used as drinking water at some point, has been contaminated. This more than Exhibit B8 says this. Let's look at the Red Hill Task Force, Exhibit S5. Groundwater monitoring in RHMW02, located near Tank 5, showed an increase in petroleum hydrocarbon diesel of up to 5,000 parts per billion, 500 parts per billion higher than the SSRBL approved by the Department of Health. Levels of TPHD will still persist in the groundwater beneath Tank 5, above DOH environmental action levels. And here's Exhibit N78 from 2020. Groundwater data indicate the likely presence of LNAPL on the water table, upgradient of RHM02. Humans make mistakes all the time, whether it's the unsinkable Titanic, whether it's Flint, Michigan, where residents had to deal with contaminated drinking water. Military assurances can be inaccurate. Whether we talk about the weapons of mass destruction that were supposed to be found in Iraq, whether it's claims that Agent Orange is safe, whether it's the military debris that's supposed to be cleaned up at Pohakaloa. The false bravado from the military should be seen as just that. The Navy in this case has a burden to prove that it can and will operate its tanks safely. The Navy has failed to meet its burden. Not only did the Navy fail to provide evidence that its tanks will not leak, the evidence shows to the contrary, that the tanks will leak. Not only did the Navy fail to show that its tanks are protective of the environment by the risks posed by earthquakes and corrosion, the evidence shows that their tanks are a threat to our groundwater from corrosion and earthquakes. The Navy has failed to meet its burden to show that it can timely and effectively implement the mitigation measures it has identified as necessary. Not only did the Navy fail to prove that there are no practical alternatives, but we know that there are feasible alternatives. Build new tanks above ground in a safe place, move the fuel just as the Navy did on the mainland. There's no reason why we should have a lower standard of care here in Hawaii than the folks on the mainland do. Given the Navy's track record, the inevitability of more leaks continuing to occur, and the importance of our groundwater, the Navy's application to operate the Red Hill tanks must be denied. Thank you.
Thank you, Mr. Frankel. Mr. Page for the EHA.
Nothing for closing.
All right, thank you. Councils, at this time, I'd like to have a conference with councils. Perhaps my sense is to work out a schedule and that this discussion can be had off of live stream. And we may then come back on and put on record, if you wish, any resolutions that we reach with regard to post-hearing schedule and the like. Any comments on that? I'm suggesting at this point we either go into a private conference room or we stop live streaming for a moment.
Can we take just a brief recess to
Discuss that?
no,
That's
just
fine.
take a break in general. Just take a break. We've been going for an hour and 15 minutes.
Yes, good
And
idea.
then I would suggest maybe a private conference, and we haven't done that. We should probably discuss some things.
Okay, why don't we take a 15-minute break? Is that good for everyone?
Thank you.
All right, we will resume at around 10:30. councils, I've set up the breakout room for a conference. Can I have you all go into the conference room? I'm gonna need a moment to open it and stuff, and you'll see a join button. And at that point, you click the join button and you'll be moved into a private conference room, okay? So, any questions? So I hope I've done that right. You should be able to see a join button at this point. No, you're not seeing it? Okay. Hmm. Maybe I've done the reverse. I've set it up for people other than councils to go into the room. So let me reset that. Sorry. It'll take a couple minutes or so because I've got to undo it, and it'll take time to undo it.
You successfully invited Uge, our colleague, and she's in the conference room.
It shows that a Frank Chiaffi is in the conference room. And the conference room is closing in 14 seconds. So
Yeah, I think you did invite, Frank was not intended to join the conference, so I think you did invite those that were not council.
yeah, I did it the reverse. So yeah. Okay, so let me see if I can get this thing restarted and set up right. Okay, I hope I've done it. I hope I've done it correctly now. So let's see. All right, looks like it has. You should see a join button, and we will meet in the conference room. make sure that everyone got back okay. I think we're missing a few people. Let's see.
The transporter may have taken someone to a different planet.
Or maybe the experts have logged off because our court reporter is here, Navy lawyers, BWS lawyers, EHA, Sierra Club are all here. So I think we can proceed. Mary Ann?
I'm ready, thanks.
Okay, we're going to go back on the record. Okay, back on the record, during a conference with counsels for the parties, we've agreed to the following schedule. Upon receipt of the transcript, the parties will have 1 week to present a motion with regard to pending concerns related to the testimony of Mr. Stanley and the information that he relied upon. And the schedule agreed upon is that 1 week from the receipt of the transcripts will be the deadline for the filing of any such motion. 1 week after that will be the deadline for responses from non-moving parties. And then 1 week from that, an opportunity for the move on to reply. And then there will be followed with a ruling from the hearing officer on the motion, which will trigger then a 45-day time frame for the parties to submit their respective proposed findings of fact, conclusions of law, and recommended decision for the permit application at issue. See if I have I missed anything anybody else wishes to note for the record? All right. I think that's it. That concludes our hearing. I want to thank councils for again, you guys have been tremendous in terms of your collegiality. I understand that the tremendous concern and the importance of the issue. So I appreciate that you have been able to maintain that degree of professionalism and collegiality, even as we address the really strong felt concerns and positions in the case. So I look forward to receiving your submissions as they become due. And if there's any need for further conferences, please feel free. You can send out a message and we can organize that. If I do have questions as I receive your submissions, I may be calling for that myself. So I hope that that is okay with council. Even after the receipt of your proposed findings and conclusions, if I have questions or concerns, I would like to reserve the opportunity to be able to request a further opportunity to discuss that with you before I finalize my findings, conclusions, and submission to the director's attention. Okay, so thank you, everybody. Safe travels home. Take care.
Thank you.
Thank you.
Okay. You know what, councils, you did not let Mary Ann know about your desire for a transcript. Mary Ann, for parties who want to order transcripts, do they contact you or do they contact Andrew Rosenberg?
Contact Rosenberg. That's fine.
Okay, then I'll give councils the email address for that.
Thank you. Yeah, Andy can take care of it for me. Thank you.
Okay, thank you, everybody. Take care.
Thanks.